So continuing on looking at volumes, we're going to look at how to back up and restore volumes now. So if you grab the latest code, you'll see that there's volume backup.ps1. And again, I decided to put it into a script just so I can run through a story effectively. But if I close this, let's focus on this command first. So it should all look quite familiar now. We've got -v, but this time we've got two. So the reason is we've got one to specify the volume we want to back up. Now, this could be a directory, so we're using this now to back up volumes. We could easily use this to back up another directory on your computer and use like the zip or tar, whatever archive tool you want to use that tooling inside Docker. So the same pattern as we saw previously. But in this case, this is a volume, not a directory, not a bind mount. And we're binding that to a directory called my data inside the container. Then we've got another volume, this is actually a bind mount. So even though they're both -v, this is a volume because we're specifying a name here. This is a bind mount because we're specifying a path here, so the current directory. And this second one is basically the current directory. And if we look at the command tar, we're going to say, in the current directory, which is this second one, backup, we're going to create an archive called backup.tar. And the thing we're backing up is everything in the current directory, which if we look back here is my data, which is the first one, which is the volume. So we're saying back up everything that's in the volume and put it into a file called backup.tar in your current directory outside of the container. And then for the restore, we're doing exactly the same in reverse. So we've got two, and this is saying what volume we're going to restore to. And again, we're specifying the same backup folder. So this line is here, which is your current directory. And this is slightly different in the case of with the tar command. I think it's the C which tells it it's going to actually create an archive. And then this one, I think it's the X which tells it it's going to extract. So looking at the rest of the script, all we're doing is making sure that that volume doesn't exist in the first place, so we can run this command lots of times. We're creating a brand new volume called backup demo. This is just basically using the Alpine container so we can write something. So all I'm doing is to this backup demo volume, this new volume, we're writing a file called hello. We're echoing a file called hello with the content hello, just so we've got some data in there to back up. And then we're backing up that volume and then we're restoring it. So let's give that a run. So this is blasted through that. First of all, we're deleting the volume if it already exists. It didn't, so it's just showing an error. We're creating the volume. We're writing to the volume. So we're just doing this echo. So we've got some information inside the volume. We're creating the backup, and you can see here it says hello.txt. That's the output of this tar command. So it's saying what file it's backed up. And then the restore, which restores to another volume called restored volume. And you can see this is outputting what it's restoring. So that's the output of this tar command. So now if we look at Docker Desktop and look at volumes, we've got our backup that we created. And look at data, we can see our hello.txt. We can see the restored one, so we've restored it, and that's also got hello.txt. And also, as I said before, this backup demo volume, that could easily be a directory, a bind mount to something on your computer. So you can use tooling like tar or whatever it is inside a container to modify files or to back up or to do whatever you want to files that aren't inside that container that are just on your machine. So many use cases spring to mind. This is powerful, and the more you use this and start getting used to this pattern, the more use cases you'll find over time. To wrap up this module on storage, I just want to talk a little bit about anonymous volumes. So far when we've created volumes, we've named them with an explicit name, whatever we want. But you may have seen sometimes when you do docker volume ls, we see some random hashes. So look at this command, docker run -v. Notice how I've not specified a colon. So if I do this and then do docker volume ls, we can see it's created one of these random hashes. So this is an anonymous volume. I wouldn't recommend using this. I'd always do an explicit name, but that's where you see these. You'll also see these when a Docker file has the volume instruction. So as an example, if I spin up RabbitMQ, which does have this, and if I look at, this is the RabbitMQ Docker file, it's on GitHub, and you can see we've got this volume instruction, which is the data directory. If I search for that, that's just a variable. So that's, again, just setting up a volume within here. That will always do anonymous volumes. So if I go to here now and just stop this, and then we can do Docker volume ls, we can see that it's created another volume as well as the one we created. And if we look in Docker desktop at the volumes, if we go to 1, we can see this is kind of like RabbitMQ data. The other one is what we created, which doesn't have anything in it. Now, I've got to be honest, this volume command that's in the Docker file, I can't think of many use cases why you'd actually want to do that. The only thing I can think of is just a bit more resiliency if you want to make sure that the user has got a backup. Because remember that if you run the container again, if you run the same command, you'll get a new volume each time. So it's not like it's going to reuse that one. So it must be just some kind of like backup thing. I can't, and I have looked on Google. I've really tried to find use cases behind this, and I've not really had an answer. But the one I can think of is just giving a bit more resiliency. So it's making sure that it's backed up in some volume on the host machine, so that if you get rid of your container, you've not immediately lost your data. So that now wraps up the storage section. So hopefully you've got a very good understanding. There's obviously a lot more to this. We can bind volumes to cloud storage, but it gets a lot more involved. This is a course for developers, so I can't see you needing to do that kind of advanced thing I've never had to do it, to be honest. When you start going to production, you'll probably be using something like Kubernetes to orchestrate your containers. So it becomes a bit different how you do it. So for me, using Docker locally, I've never had to use volumes beyond what we've covered, and you probably won't either. In this section, we're going to cover Docker networking. However, this is a topic that can go quite deep, and especially if you're just using Docker for standard developer tasks, then you just don't need to go that deep. In fact, you could use it without knowing any of this stuff. We pretty much have been doing so far in this course, except for one little bit where we explicitly use the host network, if you can remember back that far. However, it's definitely worth learning the fundamentals, which isn't very complicated, as Docker does most of the work for us behind the scenes. So in this course, we'll cover networking at a basic level, just talking about things which I think you should know as a developer. If you do want to go deeper, perhaps you're running a home network and you want to run multiple Docker stuff across multiple devices, the documentation is actually really good and includes easy to follow along tutorials. So first up, let's get started and take a look at the default network that Docker uses when we do a standard Docker run command. So if you remember when we did storage and we had a command, if we did Docker volume and we could do like ls, we could do create. With networks, you've got Docker network. And again, you can do ls, you can do create, you can do rm for remove. If we do ls, then we can see these by default. And we've got this name column, which gives the name of the network. And then we've got the driver, which says what type of network it is. And you will have these three networks out of the box. And this first one is the network we're going to talk about in this section, which is the default network. So if we inspect this and pick the name, bridge, then we get JSON explaining this network, and you can see we've got a gateway, we've got a subnet. We've also got containers down here, which at the moment is empty because I just don't have any containers at the moment. If we change that, so if I do Docker run -d for detached, let's give it a name, let's say container A, and let's just do Nginx, it doesn't matter which one. And let's create another one actually, let's just do container B as well. Now, if I inspect the network bridge again, we can see in the container section, we've got two containers within this Docker network, and these each have their own IP address. And if we inspect each of those, if we do Docker PS, so we've got these two, if we take the first one and do Docker inspect, so I'm inspecting the container now, then we can see this has got a network section. So it says bridge, so this is join the bridge network, and it says what IP address. A container can be connected to multiple networks, but when you first create it, you specify one or none, and it'll use the default one. If you want it to be part of multiple networks, then you would use the Docker Network Connect. And two containers in the same network can actually talk to each other. So if, for example, let's do Docker run -IT, so interactive, let's get a terminal going, and --rm. So this just means when I exit the shell, the container will be deleted rather than just being stopped. Let's give it a different name. Let's say container C, because we've got A and B already. And this time let's do Alpine. So now I've created an Alpine container and I've got a shell in there. Let's just split the terminal. In fact, so it's at the top of the screen. I'm going to exit this one, clear the screen, and do that again. Okay, and then on this side, I'm going to do another one, but which is container D. So we've got two containers with shells in the middle. If I just split here, because I want another shell so I can run a Docker command. If I do Docker network inspect bridge, which was the default bridge, and then I can see that, so I can see my containers. So it's container D and C that I'm interested in. So let's talk to container D. So if I get the IP address here, so that's the IP address allocated to container D, which is this one. If I go over here and ping, then we can see it can access it. Now this default network is slightly limited. So you've seen the -p for publish. So you can say that one container can publish a port to another container. For the default network, you would still need to do that. In the next section, when we create custom networks, containers in the same custom network you just don't need to do the -p, all the ports are exposed. But the default Docker network is slightly limited in that case. And also you don't get the DNS-based service discovery as well, like we saw in Docker Compose, and like we'll see in the next section when we talk about creating custom bridge networks, which is actually what Docker Compose uses by default anyway.